Hi guys, I hope you're good since last video. What are the details of how messages are routed from one node to another? What system I have decided to use? How am I gonna create the documentation of my project? The code base is big enough to not cover everything, but some parts will be explained. You will get the big picture in how I have organized the project from scratch, hoping it helps you with your own. It is not easy to start. The planning phase is crucial and makes your life easy. Let's get started. Infrastructure. So I'm just going to show you what's behind it. I have created a Kubernetes cluster and I have just deployed an Agentic application. So there is one node, just one node. And here the purpose is to have a structure behind those Git agents. They're going to work on those YAML files. So that's the initial idea of the project. And after that, I'm going to send a request. And they're going to read the requests and start working, changing the file, sending a Discord notification. And after, as a human, you're going to check the Discord notification. You're going to pull the changes into your own repository and see if you're going to apply those to the cluster or not. So there's a human check behind it. So yeah. So here I'm just going to show you, I have an Nginx application. I have Prometheus running also for the monitoring. And let's just check the web page that I have put. We're going to try to exec into it and to see if it's going to give us the page. Just on localhost, should be on port 80. Nothing has changed. Internal error occur. So I might need to go inside the pod directly. Let me try SH. Okay, doesn't work. So let's just get inside of it. Okay, and let's do the curl command from here. And we get the page. Okay, Creditizens SRE all good. And that would be also something challenging to try to change this config map using those agents. And those are the config maps, and this is the one. So I have a YAML file for that. And this part of the repository of one of the agents, which is responsible of the applications deployed. The other one is more responsible on the infrastructure of the Kubernetes cluster. And this is the config map. So that's what is behind in terms of infrastructure. After the application is completely separate, we have Git repositories, as I've shown you in the first video in the diagrams. There is a human side and there is an agent side. The agent side is going to have all the agents. They have their own Git repository, SRE1 with Prometheus and some nodes, and SRE2, which has the config map, the deployment, and the service, and the main repository having everything. So those are three different agents: the main agent, Creditizens 2, Creditizens 1, SRE1 and SRE2, and there will be also a pull request agent that we don't see here. On the human side, there is the application and the infrastructure to create this Kubernetes cluster, and there is the human request file. That's where the agent are going to read what the human wants. On the main repo, that's where the human is going to be pulling those changes. Okay, so we have a full Git flow here, and this is the human prompt. Okay, I'm just telling it to write a secret message, Junko in Shibuya. So before touching at any YAML file, you need the node file to work, all the workflow. Okay, so now you're aware of how the project is structured. We've seen other videos for that, but at least here we do a reminder. And we have now the project folder structure. It's a workspace that I'm using. So there are different cargo projects combined into one. This is the decoupling, the core logic, which has all the different crates that we would need in the project: agent, commit, constant, Discord notifier, environment variable manager, the custom errors, okay, the machines, and the different functions also for the tools, the schema, the prompts, and the dispatcher, which is a very important one. So this is a full cargo project. And after here, if we check all the agents, they all have one single cargo project: human agent, main agent, PR agent, the SRE worker agent, and the SRE2. Okay, so this is the different agents. They represent nodes, and inside there are sub-agents, which are going to be working on specific tasks, specific to each agent. After we have the app, that's where you get the main.rs. That's the entry point. That's where we start everything. Yes, so you've seen the core, the agents, and the app. And I used more functions into the core. And we're going to focus on one of those, which is the dispatcher and the transmitter loop. We can't go through the full code base, but we can go in what is critical, because I've been using LangChain to make my Python AI projects. So I'm using that knowledge here to try to mimic it in Rust, using nodes, trying to pass from one node to another. So in the first video, I've shown you how I created this transmitter and dispatcher. So here I'm just going to get, so we are in the file, which is the main.rs, the entry point. I'm going to get all the agents and all the core logic. Okay, this is all my tests. And here we're going to start here by creating the routes. We're going to register some routes based on the agents, main agent, and we're using a box with boxing, putting on the heap those main agent handlers. Okay, because we're going to use channels, we're going to be transmitting those, trying to access to those through channels. We're transmitting the routes, and we're getting from that transmitter function a TX, which is a transmitter, and the dispatcher handle. After I send the route messages, I use here a struct to tell which is the next node. The first one is the initial message, so I don't put anything, because the agent is going to be pulling information from the human request file that I've shown you before. Let me just open the terminal here to show you again this human request file. So we start the agent with just a direction telling it which where does it start, but the human request is this one here. And that's what the human request agent will be able to read. And after here we send this message through the channels. Here the channels, you can't see those, but I will go into the dispatcher.rs and you will be able to see how they're organized. Okay, and after here we have the dispatcher. At the end of the application, when everything is done, it's going to handle those end of graph. It's not perfect yet, but the structure is good. dispatcher finished, dispatcher error, or join error. Okay, so we got those routes. We have registered the routes. We're using the transmitter. Transmitter is returning a TX, which is a transmitter, and the dispatcher handle. And we're using those two at the end to match on the dispatcher handle to end the graph. I call it graph because I've been using long graph, so that's why I say graph. Here we are in the dispatcher.rs, which has a thread. That's the thread is a signature function. Every single agent node will have this signature function, but inside of the function will be specific to the agent. It's implementing send and sync. That's how we can pass it through the channels. Okay, MPSC, multiple producer, single consumer. Remember that. Okay, that's the one. We are using the transmitter. We are adding the routes as a parameter, and that's where we're going to be returning the TX and the handle. And here we got the RX, which is the receiver. Okay, I mean the consumer. So multiple producer, single consumer. So that's the single consumer. Here we get one of the producers at the end coming. So what is good with channel is that you can send a lot of different producer. So transmit messages, which is TX here. And after you can receive it once. And here the dispatcher, start dispatcher, that's the handle, which is going to take the routes and the copy of the transmission message, and that's where we're going to receive it and redispatch. So we use a loop. Okay. So we have the initial dispatcher. Just let me show you here. That's where there is MPSC. Okay, and we're sending the routed message. We're going to receive those through here. So sending the routes and cloning here the transmitter. Okay, so now we can see this dispatcher. Here it is, start dispatcher. We have the RX, the receiver. We have the routes that we have registered, and we have the transmitter, transmitted message. We use a while loop. Okay, so this is a loop which will evaluate whatever comes and route it to the right node. Okay, we receive the messages with our multiple producer, single consumer. Just open the comments so you can see what I just said. So our RX is always the same receiver, but each node would send its own transmitter. So it will transmit its own message to the dispatcher, so that the dispatcher received it in this loop and knows where to send it after. Okay, so which agent to start next? Next node with the transmitted message. We receive it. Okay, and here we're going to match on the route, and we get the next node. We want to know what the net has. Each has a handler. The handler is the thread, the signature function that they're all sharing. And here we go, and we use the handler of that node, and we transmit the message like that. So each route has a handler, the thread attached. Thread is a signature function that is here. Okay, and can be shared, but whatever is inside is specific to each node. So this is how we can play with it. So that's how I play with it. I use channels, I use a thread, and I make that thread specific in each agent, so they all can have their own logic. So we can show that by going to one of the agents. Let's go in the first agent, which is the human request agent. Let me open this. We do it next. Let's have a little break. Okay, so we've seen the transmission. We're going to see now the interaction between agent and transmission. Agent node transmission. So let's do it like that. I prefer it to separate it so that it's not too much information in once. Okay, human request agent. We check the source and just give it the same name. Human request node. Okay, let me open it. Here we go. Yes, finally we got it. Okay, now let's go maybe at the bottom of this file. Let me open another agent, which is going to be one of the SRE agents. Okay, so we have those agents. I'm going to use the SRE one. So before that, here the handler that we're talking about. The human request node has at the end, put everything at the end, there is a struct, and I use the threat, I implement it to that struct, which is specific to the agent, human request analyzer handler, and the function is going to start request analysis and agentic work function. And I'm just, for the first one, use the takes clone. So that's what is interesting with using threat, is that you can just use the same signature and play with it. Okay, so here we have a takes clone, which is used by start request analysis and agentic work. Which is here. Okay. And that's the one running the whole logic, which is above. So above I'm using mini agents. Okay. We return results. I'm writing the logs. And after here we have the human request node. We run to get the response. So there is a run function at the top, and after I'm just getting some structured output of it, I check which key the structured output is empty, if they are empty or not, because I want to stop it very quickly. If both are empty, I don't want it to keep going, because the agent should be choosing one of those two to do the job. Okay, so that's why here I check this first and I stop it. If they're not empty, at this time we're going to catch what is instructed to each agent. Okay, instructions, SRE1. We get what is inside of it, and same here, we get what is inside SRE2 agent key. So that's the structure output keys, and after here we root. If it is not empty, I check again. I can route it depending on SRE1 or SRE2. Okay, we format the message. It's a CRD value. It's very convenient because you just use the JSON macro and we'll send the transmitter. So the next, we use the routed message struct. We say what is the next node, So the routed message here takes sender in the handler and the message. And I put instructions and I just get what is coming from the structure output. I log it and I do a take send. That's what is convenient. And now it's going to go, it's going to arrive here. It's going to check what is the next node, take the name of the next node after having received it, and it's going to use the handle function, which is the thread function that is shared, and use the message and the text clone, the instruction send, which is all of this. Very interesting. So that's one single agent, which is the human request agent. Okay, which is having a model. Here I'm just hard coding the model, but I have created actually constants for that. That's why it's a function. Just to swap the models as needed. And that's where I'm going to use the different machines that I have created. And the constant, I'm going to call what I need. So this is the engine to call a tool. This is the engine to create a call for the structure output. And here I get the structure output at the end with the keys SRE1 agent or SRE2 agent. Okay. So let me try to open the other agent that I said that I'm going to open, the SRE agent. You're going to see how it differs. Here the request analysis is straightforward. It's just going to go read the file human request, create a structure output, and send to the next node, SRE1 or SRE2. Here in the SRE2 agent, the worker, let's say it arrives here, as in our previous video, the example we've done. Okay, we receive the message to string, because it's a value. And after, I'm going to use the SRE2 agent node work orchestration. It takes two parameters. I'm using the struct. I'm implementing this node handler trait to the struct. So I'm using the same patterns in all the nodes. Consistency. I'm always returning results. I have my custom errors set up, so I know where it fails whenever I see an error written. And after here, we use the message transmitted, which is here. We prepare the takes for the end of the node. And here, we're going to compile everything. We're going to get those different agents, the read agent, the write agent. We're going to be logging in between. So there are several agents running. This is the commit agent. And there's another one, the report agent. But before that, we provide to the report agent some of the outputs of the previous agents. And we try to keep the initial request, so initial requirements, in the context, so that when the agents are making reports, they know what they're talking about. And after, we're going to route this message to the next agent, which is the pull request agent. When the work is done, we ask to the pull request agent to pull the work. So now let's go into the constants, or like. It looks like constant, so I'm not using const. So I found another way, which I found more convenient and more flexible, is just to use functions. And those functions, consider those as being constant because they are holding some variables or the core logic, and it's not going to change. So here I have the functions to call the LLMs, different models. Here we are in the schema state. So here I'm preparing some schema states which are matching the schema keys. For the human is SRE1 and SRE2. Okay, and after we have for the main agent, for each agent, for the PR agent, for the SRE1, for the SRE2 agent, all the structure output, and the mini agent, each of those, they will have one specific structure output. Structure output full and schema. So after having created those schemas, I need to create an object which is going to take the actual schema, matching with the types of those fields. Okay, here for example for the SRE1 there is the read agent, the write agent, so they all have different schemas. Commit agent, so as you can see I still put dict, like dictionary, instead of hash map, as I'm coming from Python, but it's the same for me. Okay, so we have those structure output created. We create the response format. So all of this we're preparing the payload. Okay, same for each agent, for each mini agent. So before doing all that, you need to go to the API to know how it is structured, API you're working with. So the tools, here are the tools, description of the tool, the function of the tool, each tool, writing tool, commit tool, merge tool, pull tool. So there are some Git tools, there are some files tools. Okay, so they linked to some function, some other crates, which have the logic of those tool functions. Okay, and after for each agent, I'm going to create their own tool from that. So the tool engine, I'll be showing you after the machine and the engine in a separate part. So there are big factories to create everything. And here, for example, for each tool, you need to say what's the name of the parameter, the type of parameter, and the description. So all the parameters is that in the payload, so that it knows how to use those tools. Here we have all the agents. So I have a big struct called agent, and I can put all the information for each agent in those. And in each node, I'm going to be just pulling the information from that agent constant. I put it in parentheses. Okay, so for each agent, SRE2 agent, SRE1 agent, PR agent, and so on, the main agent. So I'm creating those agent and mini agent huge struct information, because I will need to pull the information from it. So I'll put it like that, but it could be also in a database. Here it's just in a file. Could be just in a database, and from your node, you just connect to the database to get those information, and you launch your agent. There's different ways to think about it, depending on your needs, on your system, on your compute, and so on. So there are different ways to do it. You have to stick to one when you start, because if you change in the middle of your project, you'll get a lot of trouble. Just to tell you about my experience. And after at the end, I have the payloads. And that's where we're going to create the payloads. Those are going to be sent through the API call. Everything is prepared. There are different tools. Let's focus on the tools a little bit. So you've seen the constants. I've created tools. Let's focus on this one here, the write file tool. After they all follow the same kind of structures, there are input parameters. There is a function linked to a crate. The crate is returning a result. That's why we're matching on it. So this was my big lesson around this. is returning results makes life easy. Because after you can use the question mark and it propagates the error. It's very convenient, really. So let's go into the write file .rs that we call from here, from the tool function. What we want the file contents. In Rust you can do that. You can put file content as parameter. You can use let file content and do anything and have to return it, but actually you don't need, here I don't need to return it. I could have done just a match pattern directly, but it's fine. I just keep it like that. Agent write file tool. This is where the agent is using it. Tool. Okay, so that's how I'm going to be creating the tool engine. And that tool engine is using that tool function. That tool function is calling the crate, which is having those parameters, file path and file content, which needs the name, the type, and the description. Okay. And after here, I've set a special error for that create tool engine error, so that if there's any error, I know where to go directly and check. So here I open the file. I use append for the moment because I'm playing with it with the not file. I just want to see what is being added to the file. But actually here in my application I would have two different tools, one to write append to a file and one to write a file completely. So to change all the content of the file, completely rewrite it, I would separate it into two different tools. Okay, so use append, but can maybe find a way to have or append or write entire file. Tool. Okay, close it. And after, we're just gonna be writing into the file the manifest content or the information if it is a not file. That's why you need to be very precise with the prompting, because I've been putting manifest in the prompt. So you've seen in the example that I've run that we got some manifest. We got some, it was talking about Nginx and YAML inside the notes instead of transmitting the secret message. Okay, here, not subscribed, 89.80%. Please subscribe. That's the viewers. Machines and engines, functions. So here we go into all the machines that I've created. So I created this system of having engines and machines. Machines are very targeted functions which are doing just only one thing, and the engines are the different combinations that I would need in my application. And after, from the nodes, I would just call an engine to do this, an engine to do that, and underlying just under that there will be those machine functions. API call machine, API response machine. Those are the mini functions. History update, because when you're calling the tools in the loop, you need a history, so that your agent can use another tool if needed. Okay, execute tool machine. This is just one to execute tools. That's where I'm adding all my tools. As I'm creating tools, I'm adding tools to that function. So I'm missing some tools in that function. That's why we didn't get the commits and the pull and the merge done. That's what I'm going to fix in the future. And here we have the machine constructors, as I told you, all the mini functions. And after we have the engines. Here I have created also custom errors, custom result errors. Here I have specific agent schema engine, tool engine. And after you see I put some explanation just above those functions. This will be at the end of the video, you will see why I'm doing that. Message format engine, create model setting engine. Okay, so you understand the logic around that. I put all in one file so that I can use my control just to check on the names. Control F. I'm a Control F coder. Here I just added the LSP for Rust with Rust Analyzer in NVim, but I'm not using it. I prefer to use Micro, and in Micro it's very I don't know, I prefer to use Micro for the moment. I try to force myself to use NVim as I'm using it now. Okay, so here we have the payload, switch your output. So this is the big function which is doing the loop. It'll be interesting to see it, to the details. Okay, so endpoint, history, payload, model, and tools. Max loop. Okay, this is the loop counter. Because when it's hallucinate, it can loop forever. We want to stop it. We want to have a limit. And we have a custom error for that. When the loop, the max loop is reached. After we have the LLM response, we're going to call the API, endpoint, and payload. We can use the payload that we have put here initially, but the payload is going to evolve as we're calling tools. Okay, if some tool calls, if there are some tool calls, if it is empty, so if there's no tool calls actually, this is our final answer. So we're going to loop until the LLM stops calling tools and provide us a final answer. Okay. Tool call. Tool call is tool calls 0. The output execute tool machine. We're using the machine. We get the function name and the function arguments. Okay. And from that, we're going to go into the tool response. Okay, we use this tool output. So we're going to put here and the message to append for the history. We want the tool call ID, we want the tool output, which is the name on the arguments, and we want to say that it's a tool. And we append using the append message to history. Okay. Message, the new messages, we have the history. We want to update the payload now to make a new call. So we get that history, we do an iteration, we're going to map, creating a new hash map, and we're going to insert here, you know, the way you do the prompting. You have a role, you have content, we get the content. If tool call is not empty, we're going to insert the tool call ID that we got before. Okay. So the tool response, we update the history. We get an history a little bit longer, and after we go here, we collect everything in the vector. Now we can use it for the payload. So I'm using the same name, so I use the start, and here we go. Model, so that we update the payload. And we call, so I don't put any tool choice, it's disabled. Just the tools and no response format here, so no structured output here. Because I need a separate function for that. That's how the API I'm using is, it's having some limitations. You can do tool call and at the same time asking for structure output. So I had to separate it in two different functions. That's why here you see there is another function here called structure output. So you can see I'm gonna return results everywhere. Just to show you, I've created custom results, custom errors, app errors, so I'm using my custom results. Okay, so we got the payload, and after it goes back in the loop. Goes back up here. You see everything is wrapped in the loop. The only way to exit is to stop calling tools. Okay, and the max loop counter is increasing. So as the max loop counter is not reaching the maximum, we keep going into this logic of checking if there's a tool call, calling a tool. Just let me check loop counter. I just want to see when this is where I'm going to increment it at the end when I'm done with this payload update. Okay. So this is just one function. I show you into the details. After we have another for structure output. Structure final output from raw engine. Okay, we're here the payload. There's no tools. Instead, there is the response format here. So response format, that's where I create it. This machine, this engine, and after it's done. Okay. So we've seen our machines, idea of how a machine works, mini functions, and engines. How those bigger factories engines are using the mini machines. And after the nodes are going to be calling that. We can now see the prompts. How did I organize those prompts? Let me just go to the right file. Hope I'm going to be able to open it straight. Yes. Okay, all the writing that I see on top, you will see at the end of the video why I'm doing that. Use a type and static string reference. Okay, and %str. That's how I've organized it inside the hash map, and I use function. So they're all functions so that I can call those and fetch what I need from it. They're all using a system prompt, and there will be one for each mini agent. Okay, so use a type system, and I use raw strings so that I can write whatever I want. The schemas. Let's look at the schema structure also. So it's pretty straightforward, all those stuff. I have a get schema fields. This is just a helper function that I needed. Okay. And after here, I'm using also functions. So human request agent schema is a public function, so I can call it from anywhere. I'm just going to put the comment here, just a helper function. And I get the schema prompt. Just going to save it. And here, human request agent, for example, this one is SRE1 and SRE2. And after I put the description of what is expected. Okay. So function, SRE1, SRE2, a unique list of instructions for SRE1 agent, otherwise leave it empty. If concerning SRE2, if SRE2 tasks, leave this empty and make sure it's a valid JSON string. So basically that's how I do for all of the agents. This one here, I might need to improve it because I still put here manifest. So this word, there are some confusions. String of the instruction, an explanation, what have to change in the manifest that you are aware of in order to meet requirement. I said that what you are aware of because I'm sending actually the content of it. Because before that there will be, it's called the read agent. This is the read file schema. So I think we're good with that. We've seen the prompts, we've seen the schemas, the machines. You can pause the video and see the details of the prompts or the explanation of each field expected from the structured output. Let's see the diagrams. So inside the project I always put all of those diagrams because I might lose the link. Just put a little screenshot of each. You've seen those already from the first video, but you can see here the architecture, specific constants, diagram of the agent, the flow, the project plan, structure output diagram, channels, transmitter, and so on. Okay, those are the stats. What I want to improve is the TV one. Because if you are watching on the TV, YouTube, you can use your computer at the same time. Okay, documentation. Let's see. That's what I told you at the end of the video. I'm going to show you why I'm doing those comments. So inside the target folder, when you compile, inside the debug folder, there is just the binary. But let me show you one comment. Cargo, docs, -- workspace, -- no, -- depths, -- open. So you don't need to open. But here it says doc, not docs, doc. And here you see it's going to start working. Blazing fast. This is done. And you see here I have an index.html. What amazing. Isn't it amazing? We got documentation generated for the full project. All those explanations that you've seen me writing all those comments. I told you I'm a part of the team of writing documentation straight away into the code with comments. So here we have the app. This is the entry point of the application. We'll be running the app logic. We have the core logic here. Machine function will be, we'll be using those engines. That's where the machine functions are created on the engines. And here we have the little diagram. After it's putting this from the README. And after I have the construction machines, the agent machines, the response machines, and so on. Loop control strategy, all the different strategies that I have created, some roles that I have put into the project, planning response machine, the diagram high level of execution, agent, API call, response or not, check if there is a tool call or not, on the modules. So this is same as when you go in any Rust documentation online, but this will be specific to your own project, which is pretty interesting. You get also the documentation of the mini crates and the mini decoupled mini Rust project that you have in your own, so that you can port it to other project that you have in the future. The modules, agent, commit. You see, we can see all the modules which are in the core, the main repo. So we are still in the core logic one that I've shown you initially. I'm just going to zoom in a little bit because you don't see. Get check out. Okay, here I'm just talking about the kit. SR1. So whenever I click back in another link, it's just gonna zoom in. The file checker, the merge, the prompt, the commit, the constants. Constant, we've seen it together. Here you can see all the constants that I have, the functions, because I used function for that. That's my trick. So I don't get the issue with all those channels, transmission, or I don't know what. I just use functions. Modules. PR agent, for example. Get some explanation. We get the struct, which is the handler. That's the one which is going to be implementing the threat that they're all sharing. Just exploring with you. Maybe I should have done the video just showing you the documentation. I don't know. But I found this very interesting to have a documentation generated like that. This can be shared. This is a good way also to review. If you have someone who is senior, you can maybe review your documentation just to see if there is something wrong in your application, instead of going through a huge code base. So when your code base starts to be huge, it's pretty handy to have the documentation generated like that. And we can see everything's well organized. So this depends on how much you have commented your code. After, there are different ways to comment the code. You can even have some code snippets, comments that can be executed as a test. But I'm not using this feature yet. I'm not there. So let's go step by step. I close this. I'm just going to show you quickly in the code what is actually showing. So all the README files are showing. Every single mini Rust project I put those README files, and you see at the top here, // !, triple slash above functions, for example, and the / ! At the top of your crate. Okay? Let's go to target now, and we see here is the doc. Now we have a new folder, and we can check what is inside this folder. We have all those JS files and HTML. We have seen this last part, pretty interesting in how you can create a full website documentation of your coding project in Rust. I have used the transmitter dispatcher loop to mimic what I have already done before in Python Longchain. I have used machine functions to make very specific parts, used the engines function that would use those machines in groups, just to have those different groups part of the application business logic. I have created the constant functions, easily portable and called from anywhere needed, like the nodes as input parameters, so the agent nodes, input parameters for those engines functions, Rust workspace for decoupling and the portability of some components to other projects. There are parts that I end out not using, but it has helped me more. It has helped me to explore actually and organize my ideas. Okay, let's stop here. Hope that you liked this video. Please like and subscribe, and see you next time.